Okay, so I'm going to walk through some examples of problems that are similar to the ones you guys are working on for solving equations with square roots and converting between radicals and fraction exponents. So let's try to solve this equation for x. First thing I notice is that the square root here is already by itself, which means that I'm ready to try to cancel it out. If it was not by itself, for example, if it had 1 plus over here, I would need to get rid of that number first by moving it to the other side. But if it's already by itself, then the way to get rid of a square root is to square it. Just like in order to undo multiplying, we divide, or in order to undo subtracting, we have to add something. To get rid of a square root, we have to square it. And if we do that, we need to do it to both sides. On this side of the equation, what happens is that the square root and the square just cancel out, and I get 3x plus 4. And then on this side, when I have this thing written squared, that's the same thing as writing it twice. So when I write it like this, you can probably see that we need to distribute this out. So 8 times 8 is 64. 8 times negative x would be minus 8x. The inside terms give me another minus 8x. And the outside terms give me plus x squared. Not every problem requires you to do this step, but if there's an x over here on this side of the equation that's not in the square root, then you might need to do this distributing step. Now I will combine these like terms, and I'll also put this side of the equation in the normal order. The normal way to write a polynomial like this is to write the largest exponent first. So I'm going to take this x squared and write that first. Now I have these two x terms give me negative 16x. And then this 64 gives me plus 64. Looking at this equation, you might feel like the best way to solve it is to try to get x by itself. But we have a problem there because we have an x squared term and we also have terms with just x's. So there's no easy way to get x by itself. Instead, we will have to use one of the methods for solving a quadratic equation. To use those methods, we need to get 0 on one side of the equation. So I'm going to subtract the 3x and the 4 from both sides of the equation. On this left side, now I have 0 equals x squared minus 19x plus 60. Okay. So now, is this right? Yeah. So now I have a quadratic equation, an x squared, a middle number, and a last number. We could solve this equation a few different ways. We could try factoring it. We could try the quadratic formula. We could try completing the square. I'm going to try to factor this. I'm trying to think about what the two numbers could be. Oh, okay. So I want two numbers that multiply to equal 60 and add up to 19. So let me take 60 and let me try dividing it by some numbers. 60 divided by 2. That gives me 2 and 30. That's not going to get me to 19. 60 divided by 3. That gives me 3 and 20. Nope, I can't get 19 from those two. 60 divided by 4, I get 15. So a 4 and a 15, I can get 19 from these numbers. So this equation is the same as x minus 4 times x minus 15. Negative 4 times negative 15 makes 60, and negative 4 plus negative 15 makes negative 19. So this is the correct factoring of this equation. And I'm looking for the values of x that make this come out to equal 0, which happens when either this first part equals 0 or this second part equals 0. If either of these two parts equals 0, the whole thing will equal 0. Then I'll just finish solving for x. I get x equals 4 and x equals 15. So these are the solutions to this quadratic equation. However, anytime we're solving for a square root and we have an x on the inside and an x on the outside, we have to be extra careful about the solutions that we find at the end of the process, because it turns out that sometimes we get extra solutions. If there are solutions, we will find them, but we sometimes get extra numbers. So we need to take both of these numbers and check them in this original equation to make sure that they're actual solutions. So let me check this one first. Square root of 3 times 4 plus 4 equals 8 minus 4. 3 times 4 is 12, so this is the square root of 12 plus 4 equals 8 minus 4 is 4. This is the square root of 16 equals 4. So this is true. This solution works. This solution, let's see what happens. 3 times 15 plus 4 equals 8 minus 15. 3 times 15 is 45. 8 minus 15 is negative 7. This is the square root of 49 equals negative 7. And the square root of 49 is positive 7. So this equation, or this solution, works in the equation that we got after we squared everything, but it does not work in the original equation. We call this an extraneous solution. So this one is not correct. This one is correct. The only correct answer to this equation is x equals 4. Sometimes they both work, so it doesn't always tell you, just because you found that the first one works, that doesn't tell you whether the second one will work or not. So you need to always check both answers in the original equation to see if they work. Okay. The other type of problem is slightly easier. Not all of the solving equations require you to do this, only if there's an x on the inside and an x on the outside. If it's just one or the other, then you can do the same process of getting the square root by itself and then finding x. But we only get the extraneous solutions when we have x's in both places like this. Okay. Let's try to use some of the exponent rules to write this expression as something with a fractional exponent. You could do things in a few different ways. The first thing I'm going to notice is that when I have this square root, that's the same as to the 1/2 power. If there's a number next to this symbol, then that number is the bottom of the fraction. For example, if it had a little 3 here, I would have written to the 1/3 power. If there's no number written here, it means it's a square root, and the number is 2. So I used first the rule that this radical turns into a fraction. Now I'm going to keep going. I know that having an exponent, a base with an exponent on the bottom of a fraction is the same as having that be a negative exponent. So instead of 4 over x to the 5th, this is the same as 4 times x to the negative 5th. And this is still to the 1/2 power. And now I can take this exponent and I can kind of distribute it to the inside. 4 to the 1/2 times x to the negative 5 over 2. I took the 1/2, I put it on the 4, and I also multiplied the exponent on the outside with the inside exponent for x. So when you have an exponent on the outside, anything on the inside gets that exponent, and if it already has an exponent, then the two exponents multiply together. Okay. Now 4 to the 1/2, you could type it in a calculator, or you can know that 1/2 is the square root of 4. So the square root of 4 is just 2. So here's our final answer. This expression and this expression are equal to each other. Any number that you choose for x that works in this expression will give you the same answer in this expression. Okay. Now let's kind of go the other direction, where we were starting out with a bunch of exponents, and we want to use the exponent rules to combine them together and then write the answer as a radical. So the first thing about this is I see I have a negative exponent. I'm going to write this as x cubed times x to the 1/4 divided by, so the negative exponent makes it 1 over x to the 1/2. Okay, now I've got a fraction on the bottom of a fraction, which is like writing this top part is being divided by 1 over x to the 1/2. Now when I'm dividing by a fraction, the rule is keep, change, flip. So I'm going to keep this first part, change the dividing into multiplying, and then I can just flip this fraction and write x to the 1/2. You don't really need to write this middle step, but if it helps you to see it, I wrote it. So x to the negative 1/2, negative on the bottom turns into just regular, multiplied with a positive exponent. Because the negative flips it, and then we use the keep, change, flip rule to flip it again. So a negative exponent on the bottom just turns into a regular multiplying positive exponent. Okay. Now I have 3 x's multiplied together, all with different exponents. And the rule here is if I have the same base multiplied, the exponents are going to add together. So this is going to be the same thing as x to the power of 3 plus 1/4 plus 1/2. So now I just need to combine these numbers together into a single fraction. To do that, I'm going to get a common denominator. So I can put 3 over 1 and multiply the top and the bottom by 4. That's 12 over 4 plus 1 over 4 plus 2 over 4. So 3 turned into 12 over 4, 1/4 I keep, 1/2 turns into 2 over 4. So now these 3 pieces that I'm adding together all have a common denominator. 12 plus 1 plus 2 is 15 over 4. So now I've taken this expression and I've written it so it just has one exponent. And now I want to take this and write it as a root or a radical instead. And the rule is that the bottom becomes the number with the root, and the top is the exponent. So this expression is the same as this expression. Feel free to send me any questions about this. I hope this was helpful. And if you have any specific questions about one of the problems that you did on the quiz, I can try to give you feedback on that as well. I hope everybody's having a great day, a great week. Let me know if you need anything.